In this video, we're going to begin our discussion of graphing lines. And to begin that discussion, we're going to start with a very simple example. X plus y equals 5. So what we want to do is we want to come up with a bunch of x and y values that satisfy this equation, which means we want to come up with a bunch of x and y values so that if you add those two x and y values up, you get 5. X plus y equals 5. So let's make a little table of some x and y values that add up to 5. One example that I'm coming up with is 2 and 3. Another simple example would be 0 and 5. Those two numbers add up to 5. An x and y that add up to 5 could also be 5 and 0, or 3 and 2. And maybe I'll throw in a negative number just so you can see that these are possible. If x is -1, y would have to be +6 in order for those two numbers to add up to 5. So what we're going to do is take this list of x and y values that we have here. We're going to take each pair and we're going to turn each pair into an ordered pair, or a point. And we're going to graph all of those points and see what the graph of all of these x and y values looks like. So here, x equals 2 and y equals 3 turns into the point 2, 3. The next point we have is 0, 5. The next point would be 5, 0, 3, 2, and -1, 6. So make your own list. Come up with whatever points you like that satisfy this equation, x plus y equals 5. What we're going to do now is we're going to plot each one of these points, or ordered pairs, that we came up with that satisfies this equation, x plus y equals 5. So let's start with 2, 3. To plot 2, 3, you go to the right 2 units from the origin and up 3 units. To graph 0, 5, you don't go left and right at all, but you go up 5 units. 5, 0, you go to the right 5 units, and you go up 0 units, which just keeps you right there on the x-axis. The point 3, 2 is going to be right here, and the point -1, 6 is going to be over here. Now you can kind of see what's happening here. Every one of our points seems to be falling on the same line. And I told you earlier that you could come up with as many x and y values that satisfy the equation, x plus y equals 5, and you can plot those as well. Now if we plotted all of those points as well, what we'd find is that every one of these points actually still falls on that same line. So what we do is we connect all the dots with a line. It's not going to be perfect because this was done by hand, but we call that line there the graph of the equation x plus y equals 5. Let's do another example. Let's say instead of x plus y equals 5, we have the equation y equals 2x minus 1. We're going to go through the same process. We're going to come up with a bunch of x and y values that satisfy the equation. We're going to turn each one of those x and y points into coordinates, and we're going to graph each one of these points or coordinates on the xy plane. It may not be easy to come up with a bunch of x and y values that satisfy this equation right off the top of your head. So what we usually do is we usually pick some x values. So I'm going to choose some x values. You can choose whatever you want. I'm going to choose 0, 1, 2, say 3, and -1. Now again, you can choose whatever x values you like, but keep them kind of small because we want to be able to plot them on our xy plane. What we need to do now is figure out what each of these corresponding y values is going to be. The way that we do that is we plug the x value into our equation to figure out what y is going to be. So I'll write it off to the side. Let's start with x equals 0. We're going to plug x equals 0 into our equation. We're going to substitute in x equals 0. And what does that give us for y? Well, y is going to be 2 times 0, which is 0, minus 1. So that's -1. So our y value that corresponds to x equals 0 is -1. Let's do that again. Let's take a look at what happens when x equals 1 now. If x equals 1, we're going to substitute again our x equals 1 into this original equation. And we have y equals 2 times 1 minus 1. And what does that give us for y? Y equals 2 minus 1. That's going to be a positive 1. So our corresponding y value in this case is going to be positive 1. We can keep going, and I'll do one more. Let's go down the list and look at x equals 2. We substitute x equals 2 into our equation, and you see that y is going to be 4 minus 1, which is 3. Now you could keep going with this. Substitute x equals 3 into our equation, substitute x equals -1 in the equation, and if you keep doing that, you'll find that you get a 5 and you get a -3. So let's take each one of those x and y pairs, make them into points, and graph them on our xy plane. We have 0, -1, 1, 1, 2, 3, 3, 5, and -1, -3. Let's graph each of those points on our xy plane. 0, -1 turns out to be right here. 1, 1, 2, 3, 3, 5, and -1, -3. Now I plotted all those points very fast, so the expectation is that whenever you need to, you're pausing the video and doing this on your own. What we do is we connect all of these dots, we connect all of our points with a line, and that line is said to be the graph of our equation y equals 2x minus 1. Good work. So you may be asking, is every graph of every equation going to be a line? And the answer is actually no. We have to have a certain form of an equation for its graph to be a line. So let's talk about that. The two lines that we've graphed so far have looked like this. X plus y equals 5 and y equals 2x minus 1. To put this in fairly non-mathematical terms, if you have an equation that has one x in it and one y in it, and the power on x is the first power, and the power on y is also a first power, then the graph of that equation is going to be a line. To put that a little bit more mathematically, if an equation can be written in the form ax plus by equals c, where a, b, and c are all real numbers, then its graph is going to be a line. So let's look at the two things that we just graphed and see if that makes sense. Well, the first equation I think is pretty obviously in this form. A in the first equation is actually a 1. We don't write it in there, but there's a 1 in front of that x. The b in this equation is also a 1. The c in our equation is a 5 in this case. So this equation and this equation are both said to be in standard form. However, y equals 2x minus 1 is not in that nice standard form. Standard form actually has to have both the x and the y on the same side of the equation. So to get this in standard form, it's pretty simple. What we do is I'm going to rewrite the equation. What you can do is subtract 2x from both sides of the equation. Move things around a little bit. That's going to give us a -2x plus y on the left side of the equation. And the 2x's cancel on the right, and you're left with a -1. Now this is actually in standard form. It's in standard form with an a value, the number in front of the x, is a -2. The b value, the number in front of the y, is a 1. And the c value is -1. So this is also in standard form. Okay, it's time for your video quiz. Plot at least 4 points to graph the line y equals -2x plus 3. That's just using the techniques that we used in this video. Also, when you're finished, write the equation in standard form. All right, see you next time.